Today we will start chapter number 6 of Maharashtra State Board for class 10 standard student, and the name of the chapter is Trigonometry. Now, trigonometry is derived from three words, that is tri, gono and metron. Tri, as we all know, tri means 3, gono means sides and metron means measurements. For example, polygon, hexagon, decagon, all that gon means sides only. Hexa means 6 sides, decagon means 10 sides, and metron means measurements. So in short, trigonometry means 3 side measurement of figure which is having 3 sides. Basically that we will deal in trigonometry, and that too of right angle triangle. Okay, so we'll start. As we can see here, a triangle is given ABC, where angle B is 90 degree. So in front of angle B, the side is AC. So the side which is opposite of 90 degree is called as hypotenuse. Everyone knows this. Similarly, if you are considering angle C as theta, okay, theta is again a Greek alphabet. It is used to represent an angle. So if angle C is theta, then opposite to theta will be AB. So AB is your opposite sides. AC is the hypotenuse. Now the remaining side is called as adjacent. So BC is adjacent here. So you should name this properly: AB, AC and BC. Next, trigonometric ratios. All these things we have studied in 9th standard. It is just the revision of that. You have to name the ratio properly in this sequence: sine, cos, tan, cot, sec, cosec. Okay, sine theta, cos theta, tan theta, cot theta, sec theta and cosec theta. If you are naming in this order, then the formula is very easy. The formula for sine theta is opposite upon hypotenuse. Short form is written O upon H. The formula for cos theta is adjacent upon hypotenuse. Tan theta is opposite upon adjacent. Cot theta is adjacent upon opposite. Sec theta is hypotenuse upon adjacent, and cosec theta is hypotenuse upon opposite. As you can see, the color of sine theta and cosec theta is same. That means both are reciprocal. Sine theta is opposite upon hypotenuse and cosec theta is hypotenuse upon opposite. Similarly, cos and sec are reciprocal, and tan and cot are reciprocal. So if you want to remember this, you have to use the short forms O, A, OA, OH, AH, OA. So O, A, OA, sine, cos, tan, and remaining three are just the reciprocal of the above three. Sine reciprocal is cosec, cos reciprocal is sec, and tan reciprocal is cot. So remember the order: sine, cos, tan, cot, sec, cosec. O, A, OA. Now below, as we have seen that sine is a reciprocal of cosec, so sine is 1 upon cosec. Similarly, cosec is 1 upon sine, and if you are multiplying sine into cosec, right hand side what is left? 1 is left. So this is the formula which we have derived. It is very important to solve practice set 6.1. Similarly, cos is a reciprocal of sec. So cos is 1 upon sec. So sec is 1 upon cos, and cos theta into sec theta equals to 1. Now guess the last one. Yes, correct. Tan is 1 upon cot. Cot is 1 upon tan, and tan into cot equals to 1. Now one special formula is there, that is sine upon cos. If we are dividing sine and cos ratio, that is O upon H and A upon H, we are getting tan theta. See, O upon H divided by A upon H. So H is same, so it is getting cancelled. What is left? O upon A, and O upon A is the formula of tan theta. So this formula is also very important. Tan special formula is there, sine theta upon cos theta. You have to remember this formula while solving the exercise. Similarly, cot is cos theta upon sine theta. So 6 formulas are just the reciprocal, and these two are special formula for tan and cot. These are the revision of 9th standard. Now for 10th standard, we require 3 trigonometric identity to solve the sum. And the 3 trigonometric identity are sine square theta plus cos square theta equals to 1. Second, 1 plus tan square theta is equals to sec square theta. Third, 1 plus cot square theta is equals to cosec square theta. Okay, so these 3 trigonometric identity you have to by heart. Remember one thing, if any one trigonometric identity you are using in the sum, that is sufficient, and with the help of that you can easily solve the sum. No need to use 2 trigonometric identity. With one also you can solve the sum. Once you are finding trigonometric identity with the help of this formula, then remaining you can find with the help of this reciprocal formula. Okay, so chapter number 6, trigonometry, page number 131, your exercise is given. This is the part 1. In this part 1 we will solve starting 5 questions. Okay, and in part 2 we will solve question number 6, that is left hand side is equals to right hand side, that question. So as you can see, starting 3 questions are similar. One ratio is given. In first question sine is given, in second question tan is given, and in third question cot is given. So based on that, remaining ratios is asked. So as we have discussed in introduction, that if one ratio is given, we can use trigonometric identity, any one trigonometric identity, and find the remaining ratio. In question number 4th and question number 5th, directly ratio is not given, so we will convert it into ratio and solve. So we will start the first one. First question, if sine theta is 7/25, find the values of cos theta and tan theta. So as we have discussed, we have to use trigonometric identity. Sine is given here, so which trigonometric identity is equal to sine? So sine square theta plus cos square theta equals to 1. So that trigonometric identity we will use and start the sum. So first one, sine square theta plus cos square theta equals to 1. Now here sine theta is already given, so in place of sine square theta we will put the value of 7/25 the whole square. So 7/25 the whole square, and remaining part as it is, cos square theta equals to 1. Now take the square of 7/25. Square of 7 is 49 and square of 25 is 625, and remaining part as it is. Now next step, cos square theta is we will keep on left hand side, and remaining part we will send on right hand side. So cos square theta is 1 minus 49/625. Now you can see, you can take LCM or cross multiply. So what will come? In denominator 625 will come, and in numerator 625 minus 49. So subtract it. 625 minus 49 is 576/625. Now we have to take the square root. So we all know that the square root of 625 is 25, and square root of 576, it is also a perfect square, so square root is possible here. So we will take the square root of 576 also. So square root of 576 is 24, and square root of 625 is 25. So we have solved the first part of our question, that is cos theta. Okay, next one, tan theta. So here, as we have discussed, there is relation of sine and cos with respect to tan. So that formula we will use here. We have seen in introduction also that one special formula was there for tan. First formula was 1 upon cot theta, and the second formula was sine theta upon cos theta. Yes, this formula. So sine theta is also given and cos theta is also given. So sine theta, we will substitute the value 7/25 upon 24/25. So denominator is same, So 25 will get cancelled. So what is left? In numerator 7 is left, and in denominator 24 is left. Okay. So our first answer was cos theta 24 by 25, and the next answer was tan theta, that is 7 by 24. So you can take the screenshot and you can solve this sum. Okay. So we'll go for next sum. It is also same. Second question. Second question is, if tan theta is 3 by 4, then find the values of sec theta and cos theta. So in this question, tan is given. So which trigonometric identity is related to tan? So 1 plus tan square theta is equals to sec square theta. That identity is related to tan. So we will use this. Now we will substitute the values. So tan square theta, the value is, tan theta value is 3 by 4. So in place of tan square theta, we will substitute 3 by 4 the whole square. 1 plus 3 by 4 the whole square is equals to sec square theta. Now next step, 1 plus, what is the square of 3? 9. Square of 4? 16. So 1 plus 9 by 16 is equals to sec square theta. Next step, take the LCM or cross multiply. So in numerator you will get 16 plus 9, and in denominator you will get only 16. So 16 plus 9 is 25 by 16. Okay. So it is on left hand side. So you can change the position. Sec square theta is equals to 25 by 16. Now next step, take square root. So sec theta will be square root of 25 by 16. Very simple. Both are perfect square. Square root of 25 is 5 and square root of 16 is 4. So we have completed first part up of our proof, that is sec theta. Next, cos theta. So let's check if any relation is there between tan and cos and sec and cos. So tan is sin upon cos, but we are not having sin here. And sec, yes, sec is the reciprocal of cos and cos is the reciprocal of sec. So we can use that identity. So cos theta is equals to 1 by sec theta. Now next step, sec is 5 by 4. So cos theta is equals to 1 upon 5 by 4. So denominators, see general rule, denominator will become numerator. So 4 is in the denominator part, so it will go in numerator. It will become 1 into 4. So what is 1 into 4? 4. So cos theta is 4 by 5. Directly also you can write, you can skip these two steps which are given here in white color, that cos theta is 1 upon sec theta because it is reciprocal. So directly, if sec is 5 by 4, cos is 4 by 5. Just for explanation, I have written complete steps here. In remaining questions we can solve directly also here. So it's very simple question. First part is sec theta, and sec theta is 5 by 4. Second part was cos theta, and cos theta was 4 by 5. So you can take the screenshot so that we will move to next question. I hope you are getting this. If you are having any doubt, you can ask in comment sections. Next one, question number 3. Same way, question number 3 also, as you have seen first and second question, third also you will solve same way. Here cot theta is 40 by 9, find the values of cosec and sine. So third trigonometric identity we will use here, 1 plus cot square theta is equals to cosec square theta, because cot is given, so we will use 1 plus cot square theta equals to cosec square theta. Next, substitute the values. Cot is 40 by 9, so 1 plus 40 by 9 the whole square is equals to cosec square theta. So what is the square of 40? Yes, it is 1600, and square of 9 is 81. So 1 plus 1600 by 81 equals to cosec square theta. Next step, take the LCM. 81 plus 1600 upon 81. Okay, add the numbers, you will get 1681 upon 81. Next step, interchange the values on both sides. Cosec square should come on left hand side. Next step, you can take the square root. Cosec theta will be 16 square root of 1681 by 81. Now 1681 is also a perfect square. The square root of 1681 is 41. So 41 by 9, because square root of 81 is 9. So we have finished the first part of our proof, that is cosec theta. Now cosec and sine are reciprocal of each other. So directly we can write cosine theta is 1 upon cosec theta. Same step, to sine is 1 upon 41 by 9. So 9 will go in numerator. 1 into 9 by 41. So 1 9s are 9 by 41. So sine theta we are getting 9 upon 41. All the three questions are similar only. First you have to use trigonometric identity, and then you have to use that reciprocal formula. Any one reciprocal formula you can use and you can get the answer. So first part was cosec theta, and cosec theta we are getting 41 by 9, and second part was sine theta, and sine theta is 9 by 41. See here in the sum, yellow color is our answer and green color is the formula which we are using here. Now next, remaining two questions. These are little bit tricky questions, you have to pay attention here. Fourth one, if phi sec theta minus 12 cosec theta equals to 0, find the values of sec theta, cos theta and sin theta. So as we can see here, direct ratio is not given, so we have to arrange it in ratio form. So first step, what is given, we will write phi sec theta minus 12 cosec theta equals to 0. It is given. So arrange it first. Minus 12 cosec theta we can send on right hand side. So if negative term is going on right hand side, it will become positive. So phi sec theta is equals to 12 cosec theta. Now next step, phi sec theta means phi multiplied by sec theta, and 12 cosec theta means 12 multiplied by cosec theta. So multiplication will become division now. So take trigonometric ratios on one side and numbers on one side. Before that, we will take the reciprocal of sec. Now what is the reciprocal of sec? We all know reciprocal of sec is cos and reciprocal of cosec is sine. So substitute that value, phi into 1 upon cos theta and 12 into 1 upon sine theta. Now next step, take sine and cos on the same side. So sine theta is in denominator here. If it is going on left hand side, it will come in numerator. Similarly, phi is in numerator. So if it is coming on right hand side, it will come in denominator. So we are getting sine theta upon cos theta is equals to 12 by 5. Hope you all understood this step. Sine upon cos is equals to 12 upon 5. Next step. Now sine upon cos is the formula of what? Yes, very good. Sine upon cos is the formula of tan. So in place of sine upon cos, we can substitute tan here. So tan theta is 12 by 5. So we have got at least one trigonometric ratio here. Now with the help of this, we can find out remaining. So first of all, tan and sec is having trigonometric identity. So what identity is that? 1 plus tan squared theta is equals to sec square theta. We have seen in the first three sums. All the three identities we have seen. Put the values. 1 plus 12 by 5 the whole square is equals to sec square theta. So 1 plus 144 by 25. Cross multiply or take the LCM, you will get 25 plus 144, that is 169 by 25, and take the square root now. So what is the square root of 169 by 25? Okay, 13 by 5. Very good. So you have seen the first answer we have got, that is sec theta, 13 by 5. Now next cos. Cos is the reciprocal of sec. So with the help of that we can find cos. So cos theta is 1 upon sec theta. So directly we will take the reciprocal. So cos theta is 5 by 13. We have seen how to take the reciprocal. 1 upon 13 by 5. Then 1 into 13 by 5 this way. Okay, so directly we can take cos theta is equals to 5 by 13. Now last step, sin theta. Now here students are solving one more identity for finding sin theta, that is sin square theta plus cos square theta equals to 1. But there is no need of that. We are already having tan here, so we can use that tan and save our time. That is tan theta is equals to sin by cos formula we are having. If you are solving this formula and we want sin here, so sin will be tan multiplied by cos, and tan value also we are having, as you can see with the arrow here, tan value is 12 by 5 and cos value is 5 by 13. So both these values we can use and we will find sin. So no need to use trigonometric identity and waste time here. Directly we can use this formula and just put the values. So 12 by 5 into 5 by 13, and 5 is getting cancelled. So what is left? Sin theta you are getting as 12 upon 13. So see how simple is this. So with the help of only one trigonometric identity we have solved this sum. So first part of your answer was sec theta, and sec theta we have got 13 upon 5. Second was cos theta, and cos theta is 5 by 13. And the last one was sin theta, and sin theta is 12 by 13. Very simple. So hope you understood this sum. It is very important question. It can come for 4 marks. Same type of question is there in solved example also. Okay, so you practice that question also. Last question of our first part, that is fifth one. If tan theta is equals to 1, then find the values of sin theta plus cos theta upon sec theta plus cosec theta. So here tan is given, so with the help of tan we can find out sec, and we require sec. Okay, so trigonometric identity for tan and sec is there. 1 plus tan square theta is equals to sec square theta. That trigonometric identity we can use. Put the values. 1 plus 1 the whole square equals to sec square theta. So square of 1 is 1 only. So 1 plus 1 we are getting as 2. So sec square theta is 2. Now take the square root. Sec theta is square root of 2. So directly we have got the answer, because 2 is not a perfect square. So the answer will be root 2 only. Now next, sec we can take the reciprocal, and reciprocal of sec is what? Remember the ratio sin, cos, tan, cot, sec, cosec. So sec is a reciprocal of cos. So with the help of sec we can find out cos. So cos will be reciprocal of root 2. What is the reciprocal of root 2? Reciprocal means 1 upon. So if denominator is not there, directly it will come 1 upon root 2. We have seen in previous sum how to take the reciprocals. Next one, we have got sec and cos here. Now which trigonometric identity or trigonometric ratio we can find here? Now what is left? Sin is left and cosec is left. So as we have discussed in previous sums, that with the help of one trigonometric identity we can solve the remaining one. So cos we are having here and tan also we are having here. So we can use that cos and tan and find out sin here. So tan theta is equal to sin upon cos. So sin theta will be tan into cos. Put the values. Tan is 1 and cos is 1 upon root 2. So sin is also 1 upon root 2. Now only one is left, cosec theta. Now sin's reciprocal is cosec and cosec reciprocal is sin. So cosec theta is 1 upon sin theta. So what is the reciprocal of 1 upon root 2? Reciprocal of 1 upon root 2 is root 2. So cosec is root 2. So we have find out all the 4 trigonometric identity which is asked here: sec theta, cos theta, sin theta and cosec theta. Next one, substitute the values. Sin theta plus cos theta upon sec theta plus cosec theta equals to, now sin and cos is 1 upon root 2 as we can see on left hand side. Sec and cosec is root 2 plus root 2. Now denominator, root 2 plus root 2 will become 2 root 2. Root 2 plus root 2 will become 2 root 2, and in numerator we can take common. Root 2 is common, so it will come one time, and numerator will become 1 plus 1. Okay, numerator will become 1 plus 1. So 1 plus 1 is 2 root 2 upon 2 root 2. Now numerator's denominator, it will come in denominator. So that root 2 from numerator will come in denominator. So 2 upon 2 root 2 multiplied by root 2. Now 2 and 2 is getting cancelled of numerator and denominator, and root 2 and root 2 we can multiply. What is root 2 into root 2? Yes, whenever root is multiplied, root sign gets cancelled. So root 2 into root 2 is root 4, that is 2. So in numerator 1 is left, nothing is there means 1, and in denominator only 2 is left. So sin theta plus cos theta upon sec theta plus cosec theta is 1 upon 2. So you can take the screenshot. Hope you like this.